And look, it's a triangle to launch cannonball. That's what it looks like.
So let's launch a cannonball. Okay, let's see what happens. At 46 degree, it goes. I mean, way far, right? Let's
Yeah.
decrease some angle. Let's see what happens. It's not that far, right?
Hmm.
Now let's make 64-degree angle. What do you think? What will happen? Hmm? As you can see, it didn't make that far, right? Now let's
Huh.
increase angle. Okay, it's 73-degree now. What happens? Yeah, it is getting closer to the cannon, yes or no? But as you can see, the height is also increased, right?
Yes.
Now let's project it at 79-degree. Let's see what happens. Oh, I mean, here the height is maximum, right? But
Huh.
the range is minimum. As you can see, it is not that far from the cannon. Now, if you, let's say, if we launched it at 90-degree, what do you think what will happen?
It will go straight up and come back down.
All right. So as you can see, it depends on the angle, right? At what angle you are projecting the ball, yes or no?
Yeah. Got it.
Let's launch a football, okay, at 49-degree. Let's see what happens. Let's increase the diameter so that you can see the ball properly. Let's launch it again. Oh yeah, it's not a football, right? Rugby ball, yes or no?
Yeah. The American football.
Yeah. Let's launch a tank shell, okay, at
Huh.
64-degree. Tank shell is not that. Okay, okay, let's make it a bit bigger. So that's a tank shell, okay.
Okay.
So yeah, it's how much? 25 meters from the cannon, as you can see. And
Hmm.
at 47-degree, it was how much? As you can see, it's 30.8 meter or more, right? Now
Yeah.
let's make the angle 76-degree. Let's see what happens. It is right here at 15 meters.
Huh.
Okay, now so now you do understand that it depends on the angle, right? At what angle you are projecting. If it's I mean 45-degree or less than that, it will go far, right, from the cannon. But if you increase the angle, height increases but the range decreases, right? Now let's
Yeah.
increase the speed. As you can see at this left bottom, it shows the speed, okay. Let's make it
Huh.
25 meter per second. Let's see what happens, okay, how far it goes. Let's launch it at 45-degree, okay. Let's launch it at 34-degree. Let's see what happens. Oh, it went out of outside the screen, right? let's
Yeah.
let's launch it at 70-degree. So as you can see, the height is maximum, right? I mean, the ball is yet to come down, yes or no?
Yeah.
So it depends on the speed as well, right?
Yes.
So whatever right now we are discussing is known as projectile motion. What it is called?
Projectile motion.
Yeah. So that is what we are going to study, okay?
Okay.
So as you can see here, the gravity is 9.81 meter per second square, okay?
Hmm.
But what if we increase the gravity? Let's say we are projecting this thing from Jupiter, okay, or some other planet which has the gravity of, let's say, 18.40 meter per second, or let's make it maximum 20 meter per second. Let's see what happens, okay.
Yeah.
Here speed is 18 meter per second, okay. Let's launch it at 38 degrees. What do you think what will happen? It will not go that far, right?
So far. Gravity is increased. Yeah.
Gravity is increased. At 45 degree, you will get the maximum range. Okay. Let's make it
Yeah.
45 then. This is 45. Okay. It's maximum. Okay. At 45. And yeah. So this is how it is. Okay.
Okay. Got it.
Shall we go to the session or what? Let's include
Huh.
vectors as well. Okay. What? Let's see what happens.
Yeah.
So at this point, at this green dot, the velocity is 0, right? At the maximum point. Yes or no?
Yes.
All right then. Did you enjoy this simulation or what?
Yeah, it was fun.
All right. So let's discuss now the theory behind it. Okay.
Okay.
Okay. So just a minute. Where is it? Where are my notes? So the simulation was for projectile motion. Okay. We just discussed projectile motion. So let's derive
Huh.
the formulas and everything. Okay.
Okay.
So so in projectile motion, object follows a parabolic path. Okay, this way. Are you getting my point?
Yes.
So let's say we are
Yeah.
projecting this ball with the speed u, and right now it is making an angle theta. So as you know, this is x direction and this is y direction. Okay.
Huh.
So in x direction, you can take the component of this velocity, right? That would be u cos theta. Yes or no?
Yes.
And in y direction, it would be u sin theta. Yes or no? I taught you this
Yeah.
thing that how to take components of a vector. Remember? Let's say this is
Yeah. I
vector
know.
A which is making an angle theta, then it will become a cos theta, this will become a sin theta. Right?
Yeah.
So we are interested to find this height and this range. Yes or no? And we are also interested in to find the total time take. Okay. Now you do know that at this point the velocity in y direction is 0. Yes or no?
Yeah.
But this u cos theta remains constant. Okay, because in x direction there is no acceleration, but in y direction there is always a constant acceleration of 9.8 meter per second square, right? That is acceleration due to gravity. Yes or no?
Yeah.
So let's discuss both these directions. Okay, if we talk about x direction, so what's going on in x direction? The initial speed in x direction is u cos theta, right? And there
Yeah.
is no acceleration. And if we talk about y direction,
Huh.
so in y direction, the initial speed in y direction, this was initial speed in x direction. The initial speed in y direction is how much? U sin theta, right? And acceleration in y direction is minus g. Yes or no? That is minus 9.8 meter per second square. Okay. Always remember downward direction is negative and upward direction is positive. Okay.
Yeah.
So acceleration due to gravity is downward. That's why we are taking its value as negative 9.8 meter per second. Now let's just focus on y direction. Okay, what's going on in y direction?
Huh.
We are interested to find this height, right? Now we do have these things that Vy is 0. Initial speed in y direction is u sine theta. Acceleration is given, that is minus g. And we are interested in to find out the height. So we can use the equation of motion, right? Do you remember the second equation of motion? That
V
is
square minus V equal
very
to
good,
2AD.
very good. Here v square is 0. U square is u sine theta, that is u square sine square theta. Acceleration is minus g, right? And d is our h. So from here you can get h is equal to u square sine square theta divided by g. Are you getting my point?
Yeah. In the previous part, we said y minus direction n. What does that mean? Means what?
This is
So,
y direction, okay? This is short form for direction, okay?
what do you mean by y direction upon u sine theta? That is just the direction of u sine theta
This
upwards.
is just y direction. I have just written it that it's y direction. We are talking about y direction here,
Okay,
okay? Here we are talking about x direction,
got it.
okay? So we found out the height, right? We got the formula that it depends on the angle, as you can see, and the initial speed as well, right? That how
Yeah.
high it will go, right?
Yes.
Now let's find out this time, okay? So how to find this time? If we can find out this time, then this time will also be same, right? So we can find out this t time, then we can find out this total time, that is time of flight, right? So let's find
Yeah.
out that time of flight, okay?
Okay.
So again, let's just focus on y direction, okay?
Hmm.
In y direction, as you know that as you can see here, we have already written it down, right? That uy is u sine theta, ay is minus g, right? And
Yeah.
vy is 0, right?
Yes.
Okay, so we are interested to find time, right? And for that we have initial speed, that is u sine theta, and we have final speed, right? That is 0. And acceleration due to gravity is, so with what equation we can find this time? What equation we can use here? That would be v is equal to u plus at. Remember the first equation of motion?
Uh, yeah.
Here final speed is 0, initial speed is u sine theta.
Yeah.
Acceleration due to gravity is minus g into t. So from here you can write that t is equal to u sine theta divided by g. Yes or no?
Yeah.
And if we multiply it with 2, then you will get total time, right? That is our time of flight. Yes or no?
Yes.
So capital T would be 2 times t. That is 2u sine theta divided by g. Understood?
Yeah. Understood.
This
Yeah.
is our time of flight. Okay?
But what was the difference between capital T and lowercase t?
See, this is small
Is
time t,
lowercase.
okay? Small time t. It's the time for the ball to reach the maximum point, okay? And after that, it is
Yes.
again small t, okay? Because it will take, for ascending and descending, it will take similar time, okay? Equal time. So that's why capital T is equal to 2t,
Got it.
okay? Now, if you want to find this range is in x direction, right?
Yeah.
So let's apply formulas in x direction and let's try to find the range. Okay.
Got it.
So first of all, in x direction, the initial speed is u cos theta, right?
Yes.
And there is no acceleration, right?
Yeah, there's no acceleration.
Okay. So how we can find this range? Range is nothing but a distance, right? Yes or no? Range is
Yes,
nothing
yeah.
but a distance.
So we can use the other formula d is equal to ut plus 1 half at square.
Yes, but that would require too much effort. Okay, I'll give you
Okay.
an alternate method. Okay, you do know that
Huh.
velocity is equal to distance over time, right?
Yeah.
So from here, can you write that x is equal to vt? Yes or no?
Yes,
You
it is
can just
equal
multiply
to.
this t here, so x will be
Huh.
equal to vt. Now here our x is our range, right?
Yeah.
Velocity here is our initial velocity,
Yeah.
and this time t is nothing but our total time t, right? Yes or no? The
Yeah.
time of flight.
Yes.
So let's just plug these values here and let's see what happens. So r is u cos theta multiplied by capital T is 2u sin theta divided by g. So from here you can say that it is 2u square sin theta cos theta divided by g. Alright,
Yeah. Got it.
this was range. Okay, that is how you find
Okay.
out range. Now there is alternate formula. Let me tell you one trigonometric formula. Okay, you can say it's
Huh.
an identity. Okay, you can write that 2 sin theta cos theta is equal to sin 2 theta. Okay, it's alright if you don't
Yeah.
remember this. Okay, but we are going
Huh.
to use this identity here. As you can see, it is 2 sin theta cos theta, right? So we can replace it with sin 2 theta. Yes or no?
Okay. Yeah.
So it will be u square sin 2 theta divided by g. Understood?
Understood. Yeah.
So you did understood projectile motion. Okay.
Okay.
All right then.
Yeah.